Chapter 10, Part 2, Continuation of the Periodic Law. So now I want to illustrate to you where you expect to find most active and most inactive elements. So here, most active element, metal, is going to be at the bottom leftmost part of the periodic table. And the most active nonmetal is in the column just before the inert gases. The inert gases are in this column. So the halogen, the fluorine atom sits right here. That's the most inactive nonmetal. This is a depiction of a simplified table of electron structure of some atoms. So when you look at this table, electrons in the 1s shell, hydrogen has one electron in the 1s shell. Helium has two electrons in the 1s shell. It goes on and on. So it turns out that the 1s shell can have only two, and so therefore helium then, all the way in the farmost right, has those two electrons in its outer shell. Come back now to helium. Helium then has two electrons in the 1s shell and one electron in the 2s shell. Go on now. Beryllium has two electrons in the 1s. All is filled all the way across, and two in the second shell, on and on, and it fills until we get to 8, which is the maximum number that can be placed in this second shell. Therefore, the periodic table switch back to sodium here. Two electrons in the 1s, 8 electrons in the two in the second shell, and now one electron in the third shell, on and on. All right. So look here. Hydrogen then is thought to have one electron orbiting outside of the nucleus. Helium expected to have two electrons orbiting outside the nucleus. Why is why is hydrogen and lithium so similar and all the other ones? Each has one electron in the outer shell. Therefore, the chemistry, the bonding properties are going to be very similar for these different elements. What are some of the type bonds that we can have? The first is a covalent bond. It's formed when one or more pairs of electrons are shared. A pair is two. So if we have single bonds, have two electrons bonded together. A double bond you will find will have four electrons bonded together, and a triple bond will have six electrons. These are all covalent bonds form molecules. This is an illustration here of covalent bond of two hydrogen atoms forming together, bonding. So this is hydrogen gas, comes this way, where the two electrons are shared between the two hydrogen atoms. Ionic bond, the second type of chemical bonding. Ionic bonding is formed when electrons are transferred from two or more atoms, and the resultant ion of opposite charge attract each other. So one or more electrons would transfer from atom A to atom B, and when you do that, you have an unbalanced then in positive and negative charges, and the two will attract each other, forming an aggregation of ions. This is an illustration of the way sodium chloride is made. Sodium here has one electron in its outer shell. Chlorine has 7 in its outer shell, but it wished to have 8. 1, 2, 3, 4, 5, 6, 7 already. Now when this electron is transferred from the sodium to the chlorine atom during the ionic bonding, you end up with this, a chlorine ion represented by Cl negative 1, and you end up with a sodium ion positive as Na plus. So this now is the way the two bond. The only thing I wish I had shown here that now the two are closer together, forming a chemical bond. Okay. Ionic bond is formed when electrons, I'm sorry, I've already shared that. So that's the picture you get. And now covalent compounds are substances whose atoms are joined by one or more pair of electrons in a covalent bond. Polar covalent compounds, what are they? Why this additional word polar? Polar covalent compounds are those in which shared electron pairs are closer to one atom of the pair than to the other, making one part of the molecule relatively positive and the other part of the molecule relatively negative. That's the case with H2O, water. You will find as we continue to examine it, the oxygen portion of the water molecule is more negative, and the electron, the hydrogen part of the molecule will be more positive. And that now forms what's called a polar covalent bond. Ionic bonds. Ionic bonds are formed by electron transferred and are usually crystalline solids with high melting point. Some ionic compounds contain a metal and a single nonmetal. Other ionic compounds contain a metal and atom group consisting of two or more nonmetals. Okay. Example here then, ionic bonding of sodium and sulfur. So notice two sodium atoms are here, one sulfur atom. When the chemical bonding occur between the three, sodium is bonded to the sodium and the two are bonded to the sulfur. Look what happens. We end up with two sodium ions, each one plus one, and each have relinquished one electron to the sulfur atom, meaning the sulfur now is S2 negative, and they will bond together to form sodium sulfide. Find the formula of aluminum oxide, which consists of aluminum and oxygen ions in this case. Here's the case. Aluminum will become aluminum 3 plus, and the oxygen will become aluminum 2 plus, always. Now, you need, the only way to have a balance of charges, you can get 2 times 3 will be 6 plus ions, and 3 times negative 2 negative will be 6 negatives. So you need 3 oxygen atoms and 2 aluminum atoms to make then aluminum oxide. Atomic groups, atom group. Atom groups appear as units in many chemical compounds and remain together during chemical reactions. For instance, the sulfate group, SO4, is an example of an atom group. When two or more atom groups of the same kind are present in the formula of a compound, parentheses are placed around the group. For instance, calcium nitrate, you put parentheses around this atom group with a 2 subscript. Okay. Precipitates. Precipitant is an insoluble substance that results when a chemical reaction in solution. A precipitant is an insoluble substance that results from a chemical reaction in solution. For instance, if you combine magnesium sulfate with barium chloride in solution here, you will have the precipitants at the bottom. Barium sulfate will precipitate from this solution mixture. Naming compounds. A compound ending in "ide" usually is composed of only two elements. There is an exception. Hydroxide, which contain the OH ion, are an exception. Sodium chloride, then. Let's see, so sodium chloride, the "ide" is at the end. Calcium oxide is there. A compound ending in "ate" contains oxygen and two or more other elements. So it must contain oxygen and must also contain two or more other elements. Example, sodium sulfate contain oxygen, sulfur, and sodium. Potassium nitrate contains potassium, which is just K, contain the nitrogen and also oxygen, potassium nitrate. Okay. Continuing naming compounds. When the same pair of elements occur in two or more compounds, a prefix such as mono, di, tri, penta, hexa, etc. may be used. For instance, carbon monoxide is CO, one carbon, one oxygen atom. But carbon dioxide is carbon O with two oxygens being indicated with the subscript 2. More naming of compounds. When one of the elements in a compound is a metal that can form different ions, the ionic charge of the metal is given by a Roman numeral. Iron 2 chloride. The charge on the iron atom is +2, so we write it here as iron 2 chloride. But you can also have iron 3 chloride, and so it has has the Roman number 3. More naming continue. The name of molecular compounds that contain hydrogen often follows the traditional name. You will find methane, CH4, water, H2O, and ammonia, NH3. A chemical equation expresses the results of a chemical change. We will talk about this a lot. So let's see here. In a chemical equation, the formulas of the reactant substance, which are called the reactants, appear on the left-hand side, and the formula of the products appear on the right-hand side. For instance, the chemical combination process of carbon combining with oxygen to yield carbon dioxide is here. Okay. Here, chemical equation must be balanced, meaning that the number of atoms of each kind of elements must be the same on both sides of the equation, and there can be no missing elements. Whatever the elements number on the left side, that same number must be on the right side. Unbalanced chemical equations have unequal number of at least one of atoms on both sides. For instance, then here. Uh, this equation is unbalanced. It has two oxygens on the right-hand side, but only one oxygen on the left. In order to balance, you need to put a 2 as the coefficient in front of the compound. Now you have 4 hydrogens on the right-hand side. You have 2 oxygen on the right-hand side. On the left-hand side, you have 4 oxygen, etc. Okay, that takes me to the end of this presentation.